project 3 for the embedded system programming class is to control the SPI interfaced 8x8 MAX 7219, that's the LED device, and the HC SR04 ultrasonic sensor. This project has two tasks. The first task is to write a user space program to poll the ultrasonic sensor to get the distance reading, and based on that distance reading you're going to control the LED pattern. Task 2 is moving the logic from the user space to drivers. Right, before we get to the task, I have to make sure that the board is set up properly. Okay, for task 1, for the ultrasonic user space code, as per the manual, you'll have to set the trigger pin to high for 10 microseconds and then set to low. This is done here. You set it to 1, sleep for 10 microseconds and set it to low. This will cause the module to generate a ultrasonic wave, and you're going to pull for this, pull for the rising edge. Once you get the rising edge event, you're going to start the timestamp counter. Let us read it, and then you're going to set the pull to read for falling edges, and then once you get the falling edge, you're going to do a timestamp counter read again. Okay. The time reference was stored in a global variable. The actual transfer of this character array takes place through this function. Here we are using the SPI DEV IOCTL command to send in one message. Next we can see the output. If you notice here, you can see the dog running, and based on the distance, the dog changes the directions. Yes, here. Okay, task 2. Here the logic is moved from the user space program to the kernel driver. I have written a IRQ handler that I registered during the driver init. This handler is called during the rising interrupt and the falling interrupt. Whenever this handler is called, first I make note of the time using the read timestamp counter, and then if the rising edge is called, then I set the time to the rising edge time, and then change the handler to handle the falling edge. Subsequently, when the falling edge interrupt occurs, same thing is done again. Only this time I change the handler to handle the incoming rising edge interrupts. For the SPI LED driver, I've made some modifications to the SPI DEV.c. I've created a SPI IOCTL command wherein I get the pattern that the user wants to display, 10 sets of patterns from the user space. That's done here, SPI IOC user pattern, and then based on the distance that I get from the ultrasonic sensor, I can get the user to give in which pattern he or she wants to display. Say there are 10 patterns and the user wants to display pattern number 2 and 3. So I get the pattern numbers, and then based on the patterns that was given before, I display them using the SPI DEV sync write. This function is executed in a loop by the kernel thread on and on until the distance becomes less than 5, and the user gives a buffer that has only two values, 0, 0. Let's see the output that I got. Okay, for task 2, the pattern that I've given is Mario jumping onto the flag and the flag coming down. Based on the distance, the pattern can change. So if the distance is between 30 and 40, you can see the flag going up and down. I know it's a bit difficult to see, but yeah. Then if the distance is between 20 and 30, you can see Mario jumping back and forth between the flag and the Here you can see Mario jumping back and forth from the flag. And if the distance is either too big or less than 20 and greater than 5, all of this is in centimeters, the normal pattern takes place. If the distance is less than 5, the animation ends.